Good morning, students. So, in today's class, we will see graphical questions on work done, that is indicator diagram, PV diagram particularly, area under the graph questions models. So, after this class, I'm going to give you one assignment immediately. You start, or whenever you will get time after the class, you can start and send me the solutions. Okay, let's start. So, yesterday, we have learned this formula, that is work formula. W is equal to P into Pf minus Pi. F minus Pi. This formula we have finished yesterday. This is the work done formula. Now in today's class, we will learn indicator diagram, that is PV graph. What is that? PV graph. That is pressure versus volume graphs. You know? So let's see what is this PV graph and how to find area bounded, when is work negative, when is work positive. Whatever the yesterday's class was there, that was basic class. One more time I'm telling, those who did not listen the class carefully, one more time go and listen, because what is isobaric, what is isochoric, all that processes you should know, then only you can solve this. Got it? And maintain separate notebook. And as I am posting this will consume less data also, and I am available. Pause the video and call me immediately. I will respond your call. I will clear your doubt, whatever it is. Sir, I have paused video here, 3 minutes 20 seconds. I did not understand this. Call me. I will explain there on. Got it? So don't search reasons, just learn. Okay. So let's start. PV graph. So the first point is what here in the PV graph particularly, which is very, very important. In motion in a straight line, you have learned area under velocity time graph gives displacement, like that, right? So here, this area bounded by PV graph, area bounded by PV graph. What is my sentence, which is very important? Area bounded by PV graph represents work done. Represents work done. So let's see some graphs and how to find area of that particular case. Okay, so what we are going to see now, how to find area. So let's see. First graph we can say. So I'm taking here pressure on this axis and volume on this, that is x-axis obviously. And if graph is a straight line which is like this, parallel to x, this is what? Volume. And this is what? Pressure. And this is volume. Now suppose this is the point where your volume is P1. What is the volume here? P1. And here this is the final point where volume is what we can say P2, and this point is, let us suppose, at pressure P. So in this case, what is the work here? Work is equal to, in this case, area under this graph, है ना? So work is equal to what? Area, and that is equal to what? This is a rectangle. This is what? Rectangle, है ना? So if I will give name like this, you can see, if I have given names like this, suppose this is A, this one is B, this one is C, and this one is D. Then area of what we can say? Area of A, B, C, D. So what you are getting? This AB into AD or DC into AB. Anything is AD, DC into AD. So DC into AD. DC is what here? V2 minus V1. So therefore V2 minus V1, and this AD is what in the graph? This P. So therefore you are getting what? Work done is equal to P into V2 minus V1 for this particular graph. So I am giving this graph as a number 1. Okay, number 1 graph we can say. Next graph, let's see, second one, second graph. So what type of graphs we are getting? Just see. So here I am taking like this graph. Again, pressure is here and volume is here. So same like this. This is volume, this is pressure. But this time your graph is something like this. Like a Boyle's law. You know? Boyle's law we have learned, no? In that, pressure is inverse proportional to volume. If you will plot graph, how we will get? Like this. So here again I am joining these points on this. So you are getting some area bounded with this. This is the area, right? I am shading this part, area of shaded part. Here also, if you want, you can shade this one. If you want, you can shade this area of this graph. That is your work done. Area under the graph gives you work done. So here, now this is which point? V1, initial volume. Initial volume is what here? V1. Initial volume, final volume is what here? V2. This one is here again. This one. This part is suppose P2. But I am taking this that as a P2. Enough. Right. And down is P1. Here it is like this. P1 we can. But here you see, if I will take this part as a dV. What is this? I am taking this part. I will change the color. So this part I am taking because I want to add this dV, volume like this. This part. This part I am taking as a dV, and I will not take here anything. I will just keep this as a P only. This side no need of P2 and all. So just P, whatever the value is there. Okay. Like this. Got it? Now, how to find the work done here? Can I write like this? Work is equal to P into dV. Here what I am writing? P into dV. Area. And here I should integrate from PdV from P1 to V2. So if you will integrate this, what you are getting? P2 minus P1. Again here also same you are getting E into V2 minus V1. If suppose like this thing is there, just whatever the V1 and V2 is there, you just integrate, you will get the same. Next one, next graph. If in question they are giving like this graph, next graph you see something like this graph. The graph is just a straight line like this. It is just a straight line. Now you see here the pressure is changing from this point to this point, but there is no change in volume. There is no change in volume. Only one V is constant. Yes or not? There is changing pressure, but volume is remaining constant. So in this case, W is equal to P into V2 minus V1. But here V2 minus V1 is equal to 0 because V2 is also equal to V and V1 is also equal to V. Therefore, W is equal to 0 in this case. Here, right? So this is, you can keep these all formulas in the boxes. 1, 2, 3 graphs. So here this one is again W and W. So this one I am keeping in the box, this formula also. And in this case, you got this work done because here V2 is equal to V1 is equal to V. V2 is equal to V1 is equal to V here in this graph. Therefore, you are getting V2 minus V1 is equal to 0. Right? You can draw little straight these dotted lines in the graph. This one also you use the scale. Okay. Straight you draw. This is just like this graph. Okay. So if like this graph is there, or if you will draw just this also enough. No need that much. Just that's it. Enough. This also if you will draw enough. You will understand. Straight line parallel to pressure axis. Yes, got it? Understood? So let's move ahead and see the next graph. Now next graph, suppose you are having like this. This graph is suppose something like this. This is a fourth number graph, right? So you are having graph like this. Graph is like this. Now you join this to the x and y axis, and whatever this area bounded is there, this is what your work done. This area bounded under this graph. Just use the scale and draw straight lines. So this one is P1, this one is P2, pressure axis, this is volume axis, this one is V1 and this one is V2. So who will tell what is the area under this graph now? Yes, here you will get area of trapezium, what you will get here? Area of trapezium. So if I am giving here point A, this one is point B, this C and this B. So here work is equal to area of trapezium ABCD. The area of trapezium, you know what is that? Half into sum of parallel sides. So half into sum of parallel sides, this and this, है ना? So shall I write like this? AB plus CD into this height, है ना? Height is what here? BC. So what you will get here work done in this case? Half into AB. AB is what? P1 and CD is what? P2. So I can write P1 plus P2 and this one BC is what here? P2 minus P1 and therefore work done is what in this case? This one. Got it? So this is what your work done in this case. Clear? Next one. Now, sometimes what happens? Final volume will be more, sometimes initial volume will be more. Now let's take one example. So see here, case 1, in case of expansion and compression, what I am writing, see, in case of expansion and compression, in case of expansion and compression. So let's see first case, that is expansion. Concentrate, very easy. Now एक जनरल एग्जांपल देता हूं मैं आपको. Expansion, that is number 1 case, expansion. So in expansion what happens, you are having a container, take one container like this, and here is a piston. Is a piston. Now here is a gas. Gas is here in this piston, and this is what? Initial volume. Initial volume. After some time what happens? Initial volume, this is Pi. Initial volume. Now next, again I am taking the same container, but what happens in this container, you see, now this container or this volume of this container expands, and therefore initial volume is final volume is little big as compared with the initial volume. So how it is, let's see. This is a container again, and you are having this piston now moved here. This piston is moved here. Got it? This piston moved here. So now this is a gas again. So who will tell me now this time volume is more or less? So more volume. So this is PF. PF. So what is this? Final volume. So here PF is greater than Vi. Final volume is greater than Vi. That is called your expansion. That is called your expansion. If this expansion is there, then what is the effect of on work done? First note down this and let's see ahead. What is the effect on work done? So see, as you know, W is equal to P into Vf minus Vi, and as Vf is greater than Vi, so therefore W is equal to what? Positive. W is positive. Work done is positive. Right. Next case. Suppose now what I am doing. Second point I am writing here. In case of compression. In case of, or wait, first I will plot graph also for this. Right. So expansion ke liye how you are getting graph, that is also important. So see here I am plotting that. The graph for this expansion where work done is positive is like this, straight line. Now it is straight line, increasing like this. This is P and this is P. So this area under this shaded part is positive or negative? Positive. So here work W is positive. Right? This is Vi and this is Vf. So obviously here it is what? Vf is greater than Vi. So in this case you are getting like this. Next one, second one, that is when work done is negative. So let's see this second part is complete in the green ink. Complete in the green ink. This is what? Compression. Now compression is what? Let's take example how we have taken same like this here also. So in this case, again I am taking container. Initial state I want to represent. The initial state, and here it is a final state. Okay. So in this what happens? Let me take first one piston. And here is a gas. Gas is. So this is what your initial volume in this piston, whatever the gas is. And later this one changes. How it changes? See, this piston goes down. It means what? It compresses or it expands? It compresses. So this compresses. So this is your gas now, compressed gas. This is what? Compressed gas. And this is what volume is PF here. Volume is PF. And this is your compression, and here PF is less than PI. So if I want W now, W is equal to what? P into VF minus VI. So as here VF is greater than VI, so therefore W is what? W is negative. है ना? क्या है W in this case? Negative. Or work is negative. Work is negative. And if we will plot the graph for this case, small graph I am plotting here in this case. You see here graph for this. Again you take pressure on this, volume on this axis. Who will tell me how you will get graph? How you will get graph? Your graph will be like this, something like this. This is the initial point, but maximum volume. But here it is what? Compression means final to initial we can say. ऐसे हो जाता है ना? So this one, this is the final volume, initial volume, and this is the final. Pressure increases, है ना? Pressure increases, volume decreases. That's why you see this is here. You are having more volume, but less pressure. Here it is less volume, but more pressure. That's why arrow is like this. And in this case, this is the compression, and therefore work is negative for this type of graphs. Work is negative. Understood? Clear? Note down. You can share this also. Here it is V, yeah. Here it is V, I. Yes, finished. Next. Let's go ahead. Next point. See here. Like heat, work done is depend upon initial and final state of the system. Like heat, work done is also depends on initial and final state of the system. How? Let us see below. Initial and final state of the system. And path adopted for the process. And path adopted for the process. So how it is? Let's see. So first I am plotting one graph. You see, This is one process graph, we can say. You draw the perfect curve lines. This point is A, this point is B, and system is moving like this. This is pressure versus volume graph again. Now this is the first process and this is second one. You can say path followed. So path adopted and how it is depend, that is what this example is. So what I'm doing, I'm splitting this into two parts, and how I'm finding area and work done, and what is the relation, let's see. Okay, this one I'm splitting like this. So I'm splitting this. First I'm taking this below half, that is, we can say this is point A and this one is point B, this lower one, first path, we can say. This is the first path, and this is what yours, the shaded part, area under the graph, we can say. This is volume, this is pressure. So if I will shade this part of this path 1, and let's suppose this is the area A1, area A1 for this. Next graph, this second path. So this path is like this, A to B here. This is A and this is B, and this path actually like this. So this is what we can say the area is. So now tell me which area will be more ray. This is suppose A to area for this second path. Then in this case, you can see here A2 will be greater than A1. A2 will be greater than A1, and therefore here W2 will be greater than W1. That's why I am saying you, what is that? Work is depend on path, initial and final states of the system, and as well as path adopted for the process. So note down this. You can shade this properly with the scale, area under this with the scale. Take notes and note down properly. These are the dot dots from here. Only this part. Got it? Okay. Next one, last point, is very important. In a cyclic process, in cyclic process, cyclic process, Work done is equal to the area of closed curve. Work done is equal to the area of closed curve. Area of closed curve. It is positive. Very important line this is. It is positive. That's why I'm changing color. It is positive if cycle is clockwise. Cycle is clockwise and it is negative. Very important line. Keep it in mind. It is negative if cycle is how anti-clockwise. Right? So let's see. Let's see some examples with graphs. Okay, ready? So let's see first graph. Suppose now graph is like this. Like this triangle is there. So now what? This is the shaded part. This triangle is there, and arrows are like this here, clockwise. This is how clockwise, है ना? Arrow देखो इस पे. Arrow कैसा है process का? Clockwise. This is point A. This one is point B, and this one is point C. Right. So you can draw like this lines here down below. Same time this side also. This is P. This one is P. So this is what here P1 है ना? Volume क्या है यहाँ पे? P1. यहाँ पे P2. Here it is P1. Here P2. So here work is positive or negative or clockwise, clockwise, clockwise. कैसे है? Positive or negative? Positive है ना? So therefore here W is equal to area of triangle ABC. ये अच्छे से लिखो because it mixed with this dot line. You can write little up also. And this dotted line. So what you are getting here? Half into base into height है ना? AC into BC. तो क्या आ जाएगा ये? Half into AC is what? AC P2 minus P1. BC क्या है? BC P2 minus P1. So in this case you are getting W like this for the cyclic process. Second graph. Now taking one anti-clockwise loop, and this is what we can say rectangle. What type of loop this is? Rectangle like this. You can shade this with another color if you want, so that you will understand particularly arrows and all. This is the shaded part, and this time I am taking it in anti-clockwise direction. I am keeping arrow because these arrows are very important. So these arrows I am keeping with different colors so that you will understand clearly it is clockwise or anti-clockwise. Okay. So here it is anti-clockwise I am taking, so like this, and anti-clockwise. So again you can see here this is V1, V2. Okay, this is V and this is P here. Try to draw straight lines here. Like this. Okay. So V1, this is V2, this one is P1, this one is P2. Now again you can give names also. So let's give here as the A, this is B, this one is C, and this one is D. So again here work is equal to what, or W is equal to what? Just write W, no need of, because I am having less space at this side. Okay. So what I am writing here, W is equal to area of this rectangle ABCD. So what you are getting here for this is nothing but AD into DC, है ना? AD into DC. So AD क्या है? AD P2 minus P1, P2 minus P1, and this is negative. That's why minus sign is here. And here it is what, DC P2 minus P1. So this is minus P2 minus P1 into P2 minus P1. Okay, this is what W is. You can keep it in a box. This as well as this formula. Okay, understood. And the third one, third graph, how it is third graph C. Third graph, you suppose you are having a circle like this circle, and this circle I am taking as a clockwise direction. Okay, this is what, clockwise direction. Can you see the direction properly? This is clockwise. Okay, direction has very importance. And here also again I am quoting this, right, shading. So this only area of this loop is giving you work done equal to area of closed curve. And already I have given, no. And then just to see the points, where are these? You can see these are the pressure points and these are the volume points. And so this is V2, this is V1, this is P1, and this is P2. And on this axis already you are having pressure, and here it is volume. So here area is what, see, here also positive now. What is work done is positive and negative. This is work done is negative, anti-clockwise. Here it is clockwise. Here again it is clockwise. So work done is positive. So therefore W is equal to area of circle. And as this is clockwise, so therefore it is positive. So W is equal to, here it is formula, pi by 4 into P2 minus P1 into P2 minus P1. So this is formula in case of circle. Got it? So I am giving you an assignment. You try to solve that maximum on these graphical models. Okay? And don't think otherwise, whatever it is. Okay? So whatever you have doubt, just call me and ask your queries. Okay? Pause the video and ask me there only, sir. This minute, this seconds, I did not understand. I will explain it. Okay? So let's stop here and bye for today.